I'd like to tell you how we're building personality chatbots that you can raise through a text conversation. It works in a simple way. You talk to it, and it learns to talk like you and mimic your personality. In the first part, I will describe technology and algorithms that we use. And the second part will be about use cases and products we are building based on that technology. So now let me show how we can build personality chatbot that is based on existing user messages and responds with the most relevant ones. Imagine I have all your SMS or WhatsApp messages, or any other text that you send to your friends. These messages could be possible responses of your personal chatbot. Let's call them just responses, to be sure. For the best results, you probably want to use a collection of at least a few thousand messages per user. Also, let's call context any message that someone else can send to a chatbot. So now we can define our problem for our chatbot as find the best response from a collection of user messages for a given context. Usually, you'll have just few good responses for the context, but the most part of them will be irrelevant. In our example, the context is, let's go to an early movie. This is someone texting to a chatbot. The response, OK, which one do you want, looks pretty relevant. Also, you can reply, sure, what time are you free? But you can't just go with where do you live or that's a lot of money. These are irrelevant responses. So our system has to decide which responses are good or relevant and which are bad. A couple of years ago, we would start to solve this task with some feature engineering, bring some folks to annotate training data, build dependency trees, do n-grams computation, or whatever old-school NLP stuff would cross our mind. Now, with modern deep learning approach, we don't need any of that. Let's build a neural net that returns a relevant score of a response for a given context. In our example, we want to compute how relevant it is to reply to the message, let's go to an early movie, with a response, OK, which one do you want? First, let's split each message into words. After that, we need to represent every word in a form that neural net can interpret. Each word representation is a high-dimensional numerical vector. You can build these vectors with Word2Vec, Glove, or any others word-embedding algorithms that you like. Let's build these vectors for the context and for response separately. Now we have a bunch of word vectors. But how we can combine them into a representation of whole message, taking into account all relations between the words? The most popular and powerful technique to do that is to use recurrent neural net. Recurrent neural net reads input text word by word and updates its hidden state after each word. Another way to think about recurrent neural net is that it has memory, which captures information about what has been calculated so far. We can use bidirectional recurrent neural net based on LSTM units. It's a common technique in modern NLP, and it works pretty well for building sentence representation. Also, we add max pooling layer right after recurrent neural net that allows us to get final compact sentence vector. So now we have two vectors, the blue one for the context and the green one for the response. Let's calculate how relevant these vectors are to each other. The easiest way to do that is to use cosine similarity measure. For relevant or similar vectors, cosine measure close to 1, whereas for irrelevant or not similar vectors, it's close to 0. Let's use cosine measure as a relevant score between the response and the context. So finally, we pull out all possible responses, calculate relevant score for each of them, and select the one with the highest score. In our example, we'll have the highest score for two relevant responses, like, OK, which one do we want? And sure, what time are you free? And lower scores for other three irrelevant responses. One of the drawbacks of our model is that we build representation for the context and for the response separately. Therefore, in many cases, the representation of the response will lack some information encoded into the context. For example, imagine there is a context what is the best AI startup in the world? And the possible response could be, it's Luca. Without context, just it's Luca has no sense, because Luca could be a name of a person or anything else. But taking context into consideration, you will know that Luca is an AI startup. Instead of building vectors for the context and for the response independently, we can apply simple attention mechanism when we build response vector. Attention mechanism gives more weights on certain part of the context that are more meaningful than others. It allows us to get better response representation and increase accuracy of our neural net. Now let me show how we can use this technology in practice. In April, right for the premiere of the new season of our favorite show, Silicon Valley, we decided to make a bot for the characters of the show. We only had subtitles and tweets as a dataset for our deep learning model. For example, for Erlich, there's just 5,000 lines. And the great thing about algorithm I told you about earlier is that this data was enough to build a bot reflected his personality. Here is an example of conversation our user had with my favorite bot, Erlich bot. A little later, we did the same for Prince. Prince had always been exactly the opposite of a talker. We used his song lyrics and interviews and everything we could possibly find to fit to our neural net. And again, it worked. One of the important things we realized building bots with personalities is that AI doesn't need to pass a Turing test to be a part of everyday life. We humans anthropomorphize everything we come into contact with. Cats, dogs, cars, even thunder and lightning. And if you give a personality to a bot, you will feel connected to it even more. Finally, we decided to allow everyone to raise a bot that would mimic your personality just by talking to it. We call this bot replicas. You can now reserve a name for your replica at replica.ai. There are still some really good names left. Your replica will keep your memories, make you more connected with your friend and yourself, do things for you, and eventually become your friend. Thank you.